Hello guys, welcome back to my channel, Boy. Another episode of Simulkuy, and today I will be talking about spreadsheet operation. Spreadsheet operation is one of the most useful operation in process simulation because you basically can do anything with that. It's like an Excel inside your process simulation. So it's very useful for a lot of stuff. So today I will deep dive more on spreadsheet operation and how it can help our simulation. Okay, firstly, you can take any case. Yeah, up to you. For me, I will take the previous case, um, which is EU operation approach for the cycle stream. Okay, so we have the spreadsheet. Yeah, first of all, we can name our spreadsheet. Yeah, give its full name for it so you will remember what it is used for. Another thing is we have this connection to import and export variables, but for me, I rarely use this page. For parameter page, this is quite important because you can specify the unit set. So the unique thing about spreadsheet is you can have a different unit set from your main case. So please beware of it. Yeah, because even though your background or your simulation unit is SI, for example, but you can have a field unit set or other unit set in your spreadsheet, and different unit set will result sometimes in different result. So, well, please beware of this page. Okay. And then also we can specify directly the number of column and number of row here. But yeah, actually we can add rows with this way, but yeah, it's quite time consuming. So if you want a larger spreadsheet, you just specify the number of column and rows that you need, and it will directly create what you decide. And then another thing is about the dynamic execution, yeah, because in steady state, spreadsheet is uh quite direct, yeah. But in dynamic, we have a choice to solve it before the pressure flow step or after the pressure flow step. If we choose its composition step, it means that our spreadsheet will calculate slower. Yeah, because composition in dynamic is the slowest calculation. Yeah, if I'm not mistaken, around 4 times step, you will calculate one time update for composition. Yeah, and lastly, always update export means that you will always update the export result. So usually I always take this in dynamic simulation. Yeah, of course, right now if because we use steady state simulation, so I don't really take care about this. And then for formula, yeah, the place where we input our formula, but again, I don't really use this page, so I will directly move to the spreadsheet. There are several ways to import and export the variables. The first thing, for example, I want to import this heat out temperature, so I will write here heat out temperature. Then I right click import variable. I search for the stream name. Oh yeah, what parameter that you want to import. In this case, is temperature of the stream. Click OK. Yeah. And you can see that we have the same value here, yeah, 90 degrees Celsius. The second thing, if, for example, you want to find the vapor flow rate. So yeah, the second way is my favorite. Yeah, I just directly drag and drop. Click here and the mass flow. So how you do it is by right click and drop in the spreadsheet. Yeah. So this way, I think it's easier for you to search for tag name. Okay. And then beware if your import variable is an input like this, yeah, it will show the color blue. And if you want to disconnect, don't press delete, yeah, because it means that you delete the value inside your simulation, but instead you need to click disconnect import export. Yeah, so it will remove the connection. Yeah. Okay. Yeah. The next thing is how to export. Yeah, it's quite easy as well. For example, I have uh this is just an example, right? I want to determine the split fraction here. Yeah, by the function of temperature. Yeah, for example, the more low the heat out, I will recycle less. Yeah. Okay. So here I will do process for example, equals to 90. So we just click our our variable here. Yeah. Or you can type also. Yeah. Plus B4, something like that. And for the formula, yeah, you can directly use the same way when you are using Excel. Yeah, it's very similar. Times 0.1 minus 0.05. Yeah, for example, like this. Sorry, 0.01. Yeah, this is just an example. So I will change this into as a fraction. Ah, okay. Okay. Then how to export? Yeah, we can right click and export formula result. Where? To where? But another thing is we can drag and drop also. This is another the easiest way to do it. Something like this. So when I change the temperature here, it will directly reflect the update, yeah, the process track. Then sometimes when you have a very big simulation file, yeah, you forget which variable you export. Yeah, because yeah, when you take a look at here and you see the parameter page, oh, why all of the flow ratio is not specificable? Also, why you don't specify any flow rate in the worksheet? So you confuse uh, h- how to trace if there's any calculation here is easy from the process equipment. You right click and open connection. Yeah, you can see that uh, there is a connection to the spreadsheet cell. Yeah. So this way you can trace your calculation better by having this feature. Okay. The last thing that I want to share is about a Boolean operation. So for example, I want to import another value, vapor temperature here. So we can create a Boolean operation. For example, if we want to check whether one value is greater than the other, so we can put like this one greater than this one. Yeah, so it's one. One means yes, yeah, right. It's correct. Yeah, 100, 110 is larger than 80. How about if we put it less than? Yeah, it will show zero. Yeah, because 110 is not less than 80. Yeah. So, is it important? Yeah, because sometimes in more rigorous simulation and high fidelity simulation, you requires some logic inside. So this operation is really needed. Nothing you also can use if. Yeah. Yeah, for example, want to revise this formula if for equal to or more than 60. So the formula will be before times 0.01 minus 0.005. But if it is not, so the formula will be before times 0.02 minus 0.01. Yeah. So here, your result will based on the formula. Yeah. If it is less than 60, yeah, for example, we put here 55. Yeah, so we'll get a different formula for this. Formula is this one. Okay. Yeah. So that is it for if operation. And then we also can have or operation. For example, we have two conditions. Yeah, for example, B4 equals to 60 or more than 60, or B3 is more than 100, something like that. You can also use. So here, even though our B4 is not more than 50, more than 60, but since our B3 is more than 100, we use this first formula. Yeah. But if I change this fit into less than 190, so it will use the second formula. Okay. So that's, or you can also use and, of course. Yeah. Then if you want other function, you can click this function help. Yeah. Okay. You can see what is the available functions and also mathematical operator here. Yeah. Or and XOR is available, logical expression, and less than, greater than, not equal to. Yeah, mathematical functions like absolute, log. Yeah, you can use all of this to aid your calculation. Of course, yeah, usually we will not use every mathematical function available, but if you go to a more advanced simulation, you will need more functions, yeah, especially Boolean operation. So that's all for my video. I hope it helps you to accelerate your knowledge and skill in process simulation, and see you in the next video. Bye bye.